Now, it does happen on occasion that when you're working on these slope of a tangent line problems, you'll be given a function, but not necessarily a specific value of x to use. For example, find the slope of the line tangent to f of x is equal to 3x squared plus 5x minus 8 at x equals a, where I don't necessarily specify what the value of a is. So with that in mind, we're just going to use the formula with the a still in there. So slope of a tangent line would be the derivative of f evaluated at a, also known as f prime of a. Now, we do have two different definitions that we're allowed to use. In the previous videos, I've demonstrated both of them. For this video, I'm going to stick with my favorite one. It requires a little less algebra in the end, or rather, a little less factoring in the end. So, this will be the limit as h approaches 0 of f of a plus h minus f of a all over h, where again, a isn't specified for us, so we'll leave it in there as a variable. So for f of a plus h, we'll be going back to the original function and replacing all of our x's with an a plus h. So 3 times a plus h squared plus 5 times a plus h minus 8, put that whole thing in parentheses, and we are subtracting what we get by replacing all of the x's in the original function with just a. That'll be 3a squared plus 5a minus 8. Once again, this is all still over h. So, a couple steps that I'm going to do here. I'm going to start by expanding the a plus h quantity squared. This will be equal to the limit as h approaches 0 of 3 times. Expanding that, we'll get a squared plus 2ah, or 2 plus h squared. We'll distribute the 5 through, plus 5a plus 5h minus 8. And we'll also distribute this minus sign through. So we'll get minus 3a squared minus 5a plus 8. Once again, all still over h. Next step of algebra I'm going to do is distribute this 3, and then we're going to start looking for some like terms to combine. So we'll see 3a squared plus 3 times 2 is 6 plus 3h squared plus 5a plus 5h minus 8 minus 3a squared minus 5a plus 8 all over h. If you arrive at this step of the process and you see a lot of stuff that cancels out, you are 100% on the right track. So 3a squared will cancel with a minus 3a squared, 5a will cancel with a minus 5a, and minus 8 will cancel with plus 8. In fact, at this step, and this is a good way to check your process, is everything that doesn't have an h left over should cancel out completely. And that's because our next step is going to be to take all of our terms that are in here and factor out that h that they all have in common. So 6ah, 3h squared, and 5h, they all have an h in common. Factoring out that h will give us 6a plus 3h plus 5. This is all still over h, and I guess I got a little excessive with the fraction bar here. So two things that can take place at this point. We can cancel out the h's, leaving us with the limit as h approaches 0 of 6a plus 3h plus 5. At this point, you can apply the direct substitution property. All of the h terms will go to 0, and you'll be left with 6a plus 5. So now, if I wanted to calculate multiple tangent lines, I could simply plug in whatever value of a would be given to me, and that would be the slope of the tangent line at x equals a. So it's almost as if we're still leaving a variable in place. So question to pose is, why not just leave the variable as x? Why do we have to bring an a into it? And that transitions us very nicely to our next section.